Hi everyone. So in this video session, I'm just going to solve one question which I shared, way back in our groups as well as in LinkedIn, right? So that question was from basic electrical engineering, and that checks your basic understanding of, you know, basic electrical engineering as well as mathematics, right? If you are good at single variable calculus, okay, so whenever you are solving any electrical engineering problem, okay, so you should not forget about calculus, right? Otherwise, you will end up making a lot of mistakes and you might also consume a lot of time, right? So let's move to the question directly. This question was, I shared from my assignment that I always share to my all the students, right? So let us read the question in the figures below. Okay, the value of the current I1 we have to find in milliampere. That is very important to keep in mind. At t equal to 4 millisecond, the waveform consists of straight line segments, right? So, this circuit is given, okay, this network is given, and there is a voltage V1, okay, that is kind of exciting entire network, right? So, there is only one source, you can say voltage source that is going to excite this entire network, okay. You will not be able to see here any sort of resistance or something. So, you might think that, oh my God, it's a very difficult question, right? And many students might be thinking that okay, there is a capacitor, there is a dependent source, and there is a waveform, right? So this problem can be of transient problem, kind of charging or discharging transient problem, okay, charging capacitor or discharging capacitor kind of problem, right? But that is your wrong assumption, okay. Please remember that you need to know which problem belongs to the transient problem and which problem belongs to it does not belong to transient problem, right? So here a DC source is applied across this parallel circuit, all the element which are connected here, they are connected in parallel, right? And and you have to also make observation that what you have to find out here. So you have to find out the current I1, right? And at this instant, okay, that is nothing but 4 millisecond, right? So you see here, the current which is flowing here, right? You can say this is 10 milliampere, okay? And you can see this is nothing but a capacitor, and the current which is flowing is nothing but Ix here, and this is Ix, okay? So, and this is a voltage, kind of ideal voltage source, okay, which is exciting this entire network, okay. So for this V1, okay, they have given some straight line segments, okay, in the form of waveform, right? So it is not a transient problem, guys. I mean, let me tell you before I start solving the question. And this question does not need you to you know write lot of equations and answer the question, okay. You can answer this question by inspection mentally as well, okay. But to make you feel better, okay, as long as we are preparing for gate examination and we are preparing for interviews, okay, written interviews and all, so we can write something. So if we want to find I1, right, and remember that we want to find this current I1 at 4 millisecond, okay. And remember this V1 is exciting this network, okay. So what we can do here is we can simply find this I1, and these are the currents which are going away from this node, right? You can say. So I1 is going to be what? 10 milliampere plus Ix plus 2Ix, okay, which is nothing but 10 milliampere plus 3Ix, okay. This is the equation that you got, okay, a simple equation just by applying a KCL at that node, right? 10 milliampere node, you can say. Now what do you want to find? You want to find I1 at 10 I1 at 4 millisecond, right? So what is unknown here? The unknown part is Ix here. If you know Ix, you can find out I1, right? So see, it is very simple here. So you have to find Ix, okay, at t equal to 4 millisecond. That is the question first, okay. So if you know this Ix, okay, let me minimize here. I think you may not be able to see me. I mean, see the part that I have written. So if you want to find this Ix, okay, at 4 millisecond, and this Ix is flowing through capacitor, right? You know how voltage and currents are related when the current flows through the capacitor. There is a C dVc by dt, okay? Ic equal to C dVc by dt, okay? Kind of differentiation is involved. Derivative is there, right? There is a derivative relationship Ic equal to C dVc by dt, okay? So your V1 is applied across these elements, right? So, you know, the Vc is going to be V1 only. You can see here, this V1 is going to be across this capacitor also, okay? So you have to just find, you know, Ix, okay, Ix at 4 millisecond, right? So Ix is nothing but what? Let me write here. Ix is going to be at 4 millisecond is going to be what? C times dv1. See, Vc equal to v1, right? So dv1 by dt at t equal to 4 millisecond. And if you have studied or you can say if you have attended my class on single variable calculus, you know that dv1 by dt at certain point is nothing but a slope, okay? So this guy is nothing but a slope, okay? So many students, what they do is they have been given a waveform, so they have kind of idea that yeah, we have to write you know, entire straight line equations, so many things, and then we will evaluate the value of a current or a voltage at that instant of time. No, that is wrong approach. Actually, that is okay, that is the correct approach, you can say, but if something is going to consume your time a lot, right, that is wrong approach, okay, as far as the test prep is concerned, right? If any question is consuming more than a lot of time that the question should not consume, right, means that is a wrong approach, you can say, okay? But conventionally it is not wrong, but yeah, you must, you know, accept this statement, okay? So wherever you find, if somebody is solving a question of a gate problem, you can say gate problem, right? And if somebody is consuming a lot of time, means that is the wrong approach. Please ignore those kind of a problem, okay? Solution, okay? So yeah. So this is nothing but what kind of slope, you can say slope or slope, okay? Slope at that instant of time. And what is the meaning of slope? Slope is nothing but change in y upon change in x, right? So at that instant of time, you know, 4 millisecond, okay, remember this is also a millisecond here, right? The time is given in millisecond, right? So what is the slope here, guys? Slope is going to be change in you know, you can say that the change in y is nothing but, you can say 3, okay? That is not in milli or something, it is 3 volt. And change in you can say that change in x is going to be what? Change in x is going to be what? Can you check here? Yes. So you will see that change in x is going to be this, right? This is a slope, okay? At this instant of time you want to find, okay? So what is the slope of this? The slope is going to be change in y is 3 and change in x is nothing but, you know, 3 millisecond, right? So I can directly write here now. Let me choose some different color as well. So C is nothing but, okay, C is nothing but what? 4 microfarad. We can write 4 microfarad, right, into dv1 by dt, that is nothing but 3 volt by 3 millisecond. Okay. Now, I think this is clear, right? You have to simply find the slope. That's it. Okay, at 4 millisecond. So if you have attended my single variable calculus, you can find out. So now you see, guys, this is nothing but 3 gone, right? So this will give you 4, okay? And you know, this is a current, it means it should be in milliampere or something. So this is micro, and this milli goes up, right? This milli goes up, okay? So it becomes kilo, right? So this will be nothing but 4 milliampere, right? I believe this is fine. Now let me recall the current that we want to calculate, that is I1 at 4 millisecond, which is nothing but 10, okay? And remember one more thing that I did not tell you. This slope is negative, guys. This slope is what? Negative, okay? So you should also put negative sign here. The slope is negative means you have to put negative sign. So this current is gonna be minus 4 milli. Okay, if the slope is negative means you have to take care of with negative sign. So this 10 milliampere, okay, plus 3 into you can say that minus 4 milliampere, okay, understood. So I can just take myself here. So this is going to give you 10 milliampere minus 12 milliampere, and which is nothing but to minus 2 milliampere. So the answer for this question is minus 2 milliampere. You see how beautiful this question was, right? So many students, what they do is they make mistake, okay, in units. Okay, you have to always take care of units. You have to take care of that slope is negative here, right? So this question is not based on the transient and something, right? This question was very straightforward. So I believe you have understood the solution, right? So the answer for this question is gonna be uh, minus 2 milliampere. What I will do in the exam is I will directly see the question, and my job is just to find out the slope, right? And get the answer quickly. Okay. So I hope you might have enjoyed this solution. You guys can share this solution among everyone. Okay. And I will be coming up with more questions of this kind and Dheeraj sir solution. Okay. So I'm gonna share my entire experience of 1 decade on this YouTube channel. You guys can also subscribe and share among everyone. Thank you.